this is we just very quickly did we did naming, right? This was the last thing that we were doing. This is I mean this is just recap of what you already know of or should know of, or you would probably have forgotten. Okay. So main chain, which is you pick the longest carbon atom chain, the longest continuous carbon atom chain. It should have the highest precedence group, and it should have the maximum substituent groups, maximum double bonds. So it should be the most important chain if you're trying to name a branch molecule. And branches are named Cl is chloro, Br is bromo, iodo, alkyl chains like methyl, ethyl, etc. OH is called hydroxy. Amine is called amino if it's a branch. Aldehyde is called formyl. Ketone is called oxo. Uh, and numbering is done to give the highest precedence group the smallest number. So the highest precedence groups are you start off with. Let's quick the far. So the highest precedence group is carboxylic acid. Okay, that's when something is a carboxylic acid, you just call it carboxylic acid. You just ignore all the rest. Then you have nitriles, aldehydes, ketones, alcohols, amines, alkenes. Okay, the importance decreases. So I did one molecule. I'm just going to do a few more, and then we'll just move on. So if I have a molecule which is, let's say, so it's got two carbon chains, and it has an OH here, and it's got let's say it's got an aldehyde, and it's got an amine. It's got a Cl as well. It's got another methyl group, and it has another methyl group. That's a yeah. Now you're supposed to name this. You're going to look for the longest chain with the maximum, the most important group in this molecule according to the precedence order is. Who can't say that's an that's an aldehyde, right? ये नीचे करो, it's an aldehyde. Aldehyde is the most important. Okay, so this at all cost has to be part of the main chain. And it should be the longest chain with the maximum groups. So the longest chain with the maximum groups, because you want the OH to be there as well. So this one is the longest chain with the maximum number of groups attached to it. Okay, what are those groups? The groups that are attached to it are methyl. Okay, so you've got a methyl, you've got amino attached to it, you've got another methyl attached to it, you've got OH attached to it, you've got Cl attached to it, right? So the longest chain has how many carbons? It's got a total of 4 carbon atoms. So that is going to be called. We're going to try and name this. That's going to be called 4 का क्या होता है? That's bute, right? And the most important group in this, according to the precedence order, is the aldehyde, right? So it's going to be butanol. Okay, AN because it's saturated, which means carbon and carbon are single bonds. It would have been EN if you had a double bond. The numbering has to be done to give the highest precedence group the smallest number. So this is going to be 1, this is going to be 2, this is going to be 3, and this is going to be 4. The branches are you've got chloro, you've got a hydroxy branch, TKC, then you've got a methyl branch, and you've got an amino branch, and you've got another methyl branch. The positions of these branches are that the methyl is on the second one, the amino is on the third one. This methyl over here is also on the third one. Then you've got hydroxy, which is on the fourth one. And you've got chloro, which is on the second one. So you just have to number and write down the branches alphabetically. So amino comes first, so it's going to be 3 amino. अच्छा, उसके बाद there is what is coming next. It's methyl is M, chloro. So it's going to be 2 chloro. Then you have hydroxy, so it's 4-hydroxy. And finally, you have 2-methyls. M is alphabetically, that's वो सबसे end पे आएगा. So M is the one that's at the end. So it's going to be, and there are 2-methyls, so it's going to be dimethyl. And you have to give the positions of each one of them. So that's going to be one methyl is on the second one, the other one is on the third one, and it's 2,3-dimethyl butanol, right? So all the branches and then your main chain. ठीक है, ये clear है? Is this clear?
Yes, sir.
So let's do a slightly smaller molecule. So I've got an alcohol, I've got another alcohol, I've got a double bond, I've got an NH2 as well. And there's 1H and bonds pure. This is 1H, right? So again, okay, let's make it a carbon chain. H ही थे ना? So I'm going to make 2 carbon chains. ठीक है, but this would be the last one. And then we'll just move on. And we'll try and draw the condensed formula for this as well. And now you have to look for the main chain with the longest possible quarters carbon atom chain with the maximum groups attached to it. So that's probably going to be this one. It's got everything attached to it. So that's the longest chain as well, and it's got the maximum things attached to it. What are the things that are attached? So that will be, you've got an alcohol, you've got a methyl that's attached to it, you've got another alcohol, you've got an amine. Yeah, so H has no importance at all. So you got these 4 things attached to it. So it's a 5 carbon atom thing. So a 5 carbon atom thing is, the main chain is going to be called pent. And it's got a double bond, so it's going to be En. It's not going to be pentane, it's going to be pentene because it's got a double bond. It's unsaturated. And now you've got alcohol and you've got amine and you've got alcohol and amines basically. So you have to look for, what would you call it? Would you call it an alcohol? Would you call it an amine? It's alcohol has a higher importance compared to amine. So you're going to call it an alcohol. This one would be called an alcohol. And so it's going to be called pentenol, right? Except that there are 2 alcohols. So which is why you're going to call it a diol, right? Because it's got 2 alcohols. And you have to give the smaller number to the highest precedent group. So you're going to count from the left side because that will give you the smaller number for the OH. So the alcohols are at positions 2 and 3. So you have to mention that the alcohol that's on position 2 and 3, and the double bond is at the ene is at position number 1. Because that sums up your main chain. It actually sums up your alcohol as well because it's the suffix group. It's what the whole chain was named on. So the only thing left is methyl, which is this, and you have to. These are the only 2 branches that are left now. So alphabetically amino, and then you have your methyl. The amino is at first position, and the methyl is on the third one, right? So that's going to be on the third one. That's it. So that's the name of the molecule. ठीक है, is this clear? बस ये last है. That's Qasim clear, Minal, Ibrahim, Hala, is this clear?
Yes, sir.
अच्छा, और फिर it's a 5 carbon atom thing. So 1, 2, 3, 4. So then you have 5. On the third one, there's another carbon atom, so we draw that. ये हो गया. Between the first and two, there's a double bond. So you got your double bond. So on the first one, there is NH2. On the second one, there's an OH. On the third one, there's a methyl, and there's another OH as well. And you don't have anything on the fourth and fifth. So that's the skeletal formula for this. So ठीक है, एक तो ये हो गया. अच्छा, so that's the first part. We're done with naming, and now we're going to quickly do isomers. ठीक है, we did all compounds. We're going to do isomers now. There is probably not going to be anything new in isomers. एक आध छोटी सी new चीज है which I'll discuss. बल्कि वो बाद में. अच्छा, isomers. Remember, you've got structural isomers. So remember the definition. What's the definition of structural formulas of structural isomers? That they are molecules that have the same. So that have the same molecular formula, but different structural formulas. So not going to go into details about this, but you should know that. I mean, you should have some idea about general formulas. There are three types of structural formulas. Number one, you've got chain isomers. So what are chain isomers? It's just that you have 5 carbon atoms. You could have another molecule with 4 carbon atoms and 1 carbon atom as a branch, or you could have another one where you could have 3 carbon atoms and there could be 2 carbon atoms as branches. They're all going to have the same number of atoms. ठीक है, that's chain isomers. Part B is that's a B here. That's positional isomers. So positional isomers are that if you have 3 carbon atoms and you have a Cl, well, the Cl could be on the first carbon atom, or you could have another one where the Cl could be on the middle carbon atom. ठीक है, इस केस में in this particular case there's just 2 possible positional isomers. Then you have a third one which is functional group isomers. So what happens in functional group isomers is that the functional group changes. कि आपके पास, if you have so you've got alkenes and cyclic alkanes. So for example, if I have an alkene with 3 double bonds, and if I have an alkane which is cyclic with 3 carbon atoms, they all pretty much have the same number of, they have exactly the same number of atoms. 3 H's, 4, 5, 6. This one would have 2, 3, 4, 5, 6. Okay. So they're going to be functional group isomers. They're different functional groups, but they have exactly the same molecular formula. Aldehydes and ketones are obviously so. For example, if I have an aldehyde, I can have a ketone as well, and that will have exactly the same formula. दोनों में फर्क ये होगा कि one gets oxidized, the other one doesn't get oxidized. So then you have carboxylic acids and esters. चलो बस इसके ऊपर खत्म कर देते हैं, टाइम नहीं जाया करते. You've got a You've got a carboxylic acid, and then you've got an ester where the same thing is in the middle. They will have exactly the same number of atoms. I said that's structural isomers. Then you have stereoisomers. So stereoisomers is that uh, molecules that have the same, उसकी definition पता होनी चाहिए, molecules that have, so they are exactly the same, just like your left hand and right hand. So that have the same uh, molecular formula, molecular and structural formulas. तो वो exactly same है. Except the difference, another difference is, but different three-dimensional geometry of the molecule, ठीक है? So the geometry is going to be different. Just like your left hand and right hand. ठीक है? तो उसमें क्या था? उसमें there were two types of stereoisomers. Number one was your geometric isomers. We did this in transition metals as well. So one of them is your geometric isomers, which are also known as your cis-trans. अच्छा इसमें इसमें कुछ नया नहीं होगा, but it's जिस तरह AS में question आते थे exactly the same way you will be asked questions about मतलब एक ही चीज है organic. Just remember AS A2. It's kind of the same thing. Geometric isomers, etc. They're going to ask you to draw it. So when were geometric isomers formed? That you needed a pi bond, and basically you needed a double bond, which would restrict rotation of the molecule. So the two sides, they would be locked in place. And what's the other one? Each carbon atom must be bonded to. Each carbon in the double bond is bonded to two different groups. You get two different groups. So for example, if you have, you can remember it's going to be trigonal planar. थोड़ा सा पता भी होना चाहिए कि this carbon is also bonded to two different groups. So there's going to be another version where you have CH3 and H, and this CH3 is actually pointing. It's actually pointing downwards. Okay, so you can still be asked to draw all of these. You can be asked to draw the double bond as well. So what is the shape of the double bond or the pi bond? It's remember carbon when it makes double bonds, it's sp2 hybridized. Okay, it's this carbon over here is trigonal planar. And the angle is 120 degrees. ठीक है तो ये भी alkenes आएगा तो हम उसको ना draw भी करेंगे. This is something, the double bond is going to be something that's very important in A levels. Benzene has double bonds, so that's why it's something that's going to be very important. तो उसके अंदर फिर detail में ना we'll do sp2 hybridization, but this is what geometric isomers are. And also remember that as the number of geometric isomers increase, so if a molecule has two double bonds, both of them are making geometric isomers, then the total number of shapes it's going to have is going to be 4. ठीक है, remember 2 per n, where n is the number of double bonds in a molecule that show geometric isomerism. And this 2 per n only works for asymmetric molecules. where the left and right side, they don't look exactly the same. So anyways, if a molecule has two double bonds, then it's going to have either both of them would be in the cis shape, or both of them would be in the trans shape, or the first one could be cis, the second one could be trans, or the first one could be trans and the second one could be cis. So there will be four arrangements. If it has three double bonds and all of them make cis-trans isomers, then the total shapes it's going to have, it's going to be eight. All three could be cis. Two of them could be cis, one of them could be trans. The first one could be trans, the other two could be cis. So there would the total of eight combinations. So there'll be, for the double bond, there would be a lot of, if you have three double bonds in a molecule. Okay? तो ये clear है cis trans? Is this clear? इस पे कोई question नहीं है, बस आगे move करें. Is this clear?
Yes, sir.
अच्छा, B पे आ जाते हैं. The next one, the next one is optical isomers. अच्छा, इसमें there's certain words that you should remember about optical isomers. The first thing is कि optical isomers is that you need a chiral center. What's a chiral center? It's an asymmetric carbon atom, which means that it doesn't have a plane or line of symmetry. ठीक है, वो left hand right hand वाला. So it's an asymmetric carbon atom where an sp3 hybridized carbon atom is bonded to four different groups. It's bonded to four different groups, and they're going to be two non-superimposable mirrored versions. You get just like your left hand and right hand. They look the same, but they are not the same exactly. So two non-superimposable mirrored version. No matter how you rotate it, it's not going to look like your left hand is not going to look like your right hand. So एक ड्रॉ कर लेते हैं कार्बन. So all four groups have to be different. So there's a CH3 and there is a CH2. So this one will have a mirrored version where in the mirror it's going to look exactly the opposite. The dot would be on this side. So you've got H. And you've got Cl on this side. Let's mirror this as well. I'm going to make it this. I'm going to look everything mirrored. I say anyway, so this is called an optical isomer, and there's a word that's going to be described an equimolar mixture of both enantiomers. There's another word that is used to describe optical isomers of enantiomers. An equimolar is called a racemic or racemate mixture. So if you have a solution and the solution has both isomers, then that's going to be called a racemate mixture. It's a racemate or racemic mixture. And it's called enantiomers. And the difference is between the two. So the difference between the two is that they both rotate plane polarized monochromatic light. It's a plain polarized monochromatic light in opposite direction. One of them is going to do it clockwise, the other one is going to do it. The other one is going to do it anti-clockwise. Secondly, there's a huge difference when it comes to chemicals, specifically biological functionality. One of them works, the other one probably doesn't work. So one optical isomer works, especially in biology, in medicine, etc., while the other one probably doesn't work. Or causes side effects. So both geometric isomerism and optical isomers, that's a huge challenge when it comes to uh, developing biological medicines or biological if you any biological application. So it's a huge challenge. Okay, that's the difference between expensive drugs and cheap drugs. Uh, so you're not sure about the yield because you're not sure which one are you getting in. Like if you make 100 molecules of this, maybe you might get, and let's say the left one is the correct one. So maybe you just end up with 30 of these and 70 of these. So that means you would need a higher dose of medicine. So a lot of time, the reason medicine is not working is that maybe the medicine that you bought was so bad that this was the one that was working well, and this was the one that wasn't working well. So that medicine had a very low yield of this one, and there were 90 of these. So uh, you see the vaccines, etc., all of the stuff. Uh, the trouble starts when the wrong one actually starts causing side effects, uh, and actually starts attacking active sites somewhere else. So the real problem begins when you have, and for that they have to be tested a lot, which is why allopathic medicines have this huge issue about the right dosage. Because you're not always sure. One company makes one medicine, like मतलब COVID के अंदर भी यही था कि one company is making COVID vaccines, the other one is also making COVID vaccines. One is effective, the other one is not that effective. So it's all about figuring out how to get the correct optical isomers. उसके अंदर ना we'll study later that there are reaction pathways which yield. अच्छा, nature has figured this out very perfectly. Natural things, any natural thing, nature is very selective. It's very stereo-selective. ठीक है? Every single one of your amino acid is actually chiral, except for one. But then alanine, like the one that has H. So every single amino acid is chiral. But every time when a protein is built in your body, your mechanism, your protein synthesis has figured out how to put in the right amino acid at the right place. Uh, Humans are really bad at it. Okay, we are not able to figure out ये वाला carbon in this shape, you get this carbon in this shape. So we mess things up. So which is why allopathic medicines, they normally have. Natural medicines, natural remedies, they don't have that many side effects. लेकिन ये भी बाद में डिस्कस करेंगे, ठीक है? So clear stereochemistry, is that clear?
Yes, sir.
Yes, sir.
अच्छा, अब आते हैं कि पहले तो basic stuff, which is what's better the arrows, right? So a double arrow, that's the movement of two electrons. Single arrow, that's the movement of one electron. And always remember the arrow represents the movement of electrons, nothing else. अच्छा, so then you have homolytic fission. Well, in that case, the bond breaks equally. ठीक है, one electron goes over here, one electron goes on this side. So that's homolytic bond fission. Then you have heterolytic fission, where both electrons go to one side. ठीक है, double arrow. So it goes, both electrons go to one side. The first one normally creates free radicals. And the second one normally creates ions. So anyway, so what's a free radical? A free radical is something that has unpaired. It's a species. It could be an ion, it could be an atom, it could be a molecule. So it's a species. It's anything that has unpaired electrons. For example, the Cl atom, right? That's a free radical. The OH, that's a hydroxy free radical. The oxygen bonds are not complete. Methyl, that's a free radical, right? If it's on its own. That means carbon's one electron is not shared at the moment. So that's a free radical. It's got unpaired electron and it's very, very reactive, right? It will try to bond with something to complete. The Cl is going to try and bond with something and it will try to complete the bonds, ठीक है? और क्या था? Electrophile. What's an electrophile? An electrophile is something which has attracted two electrons. So it's a species that is attracted to electrons. So it's something that's electron deficient or positive, right? But not only is it attracted to electrons, it can accept electrons. So an can accept a pair of electrons. So a lot of things are attracted to electrons, but if you're not able to accept a pair of electrons from it, then you're not an electrophile. A nucleophile is the exact opposite. It's something that's going to be attracted to positive charge. So it's a species, molecule, ion, atom that is attracted to positive charge. And not only is it attracted to positive charge, and it can donate electrons to it, specifically a pair of electrons. चलो ठीक है, ये सारा ना इलेक्ट्रोफाइल्स, फ्री रेडिकल्स, होमोलिटिक बॉन्ड फिशन, हेटेरोलिटिक बॉन्ड फिशन, एरोस एक्सेट्रा, ठीक है? तो ये हो गया। कल करते हैं एल्केन्स। कल एल्केन्स तो वैसे ही खत्म हो जाएगा, छोटा सा वो करना है। And probably tomorrow we'll do alkanes and alkenes, and then we'll start with A levels chemistry, ठीक है? चलिए ठीक है भाई,
ओके।
कल कंटिन्यू करते हैं, ठीक है?
ओके, अल्लाह हाफिज।
ओके देन, टेक केयर, अल्लाह हाफिज।